We will be doing some practice questions on kinematics today, and I will share the questions separately with you. For now, I will be going through the questions one by one, and we'll see how to solve them. Yeah, I've started the recording. So the question says the velocity of a body at time t is given as k e raised to minus t by 2. So this is velocity at time t. And find the distance traveled between 0. So the question is to find the distance between time equal to 0 and time equal to a. We know the relation between velocity and distance is that distance is integral of the speed. So here the total distance traveled will be integral from 0 to a, k times e raised to minus t by 2. We already know that the exponent is never a negative in value. So I'm not worrying to see where is the graph going to be positive or where is it negative so that I have to take mod or not. If you want to verify this, let me graph it and show you. I don't have to worry about the k value because k can be anything. So I'm just going to graph this exponent e raised to minus t by 2. E raised to minus t by 2. This is the graph. So you can clearly see that it never really goes in the negative region. And the k is just a scaling factor. So k could be any value and which will not affect the function going into negative region as such. Right? So the total distance here is simply integrating. We know it e raised to minus t by 2 means it's 1 by half into e raised to minus t by 2 from 0 till a. And there is a minus because it's 1 upon minus half. Minus 2k e raised to minus a by 2 minus e raised to 0. E raised to 0 is 1 and there is a negative sign here. So it's 2k times 1 minus e raised to minus a by 2. A is a value and this is the final answer. Let's see how does this 1 minus e raised to a by 2 looks like. I'll just try to graph this using x value, not the... So 1 minus. Do you see this is what is happening? So now you try to compare and understand what are you saying. If I'm integrating, which means adding all the areas under this velocity graph, what will happen to the area? The area will go on increasing, isn't it? I'm adding more and more rectangles between time 0 till time a. I don't know what a is, but could be anything on the positive x-axis. If I'm adding areas, shouldn't the sum of all areas increase? And look at the graph of the displacement or the distance. It is showing an increasing graph, which makes intuitively some sense that yes, we are doing it right. Correct? It's an easier question, but the reason I'm pointing it out to you to notice these changes is so that sometimes it is good to verify whether you're doing it right or not. Let's look at the next question. There's a particle P which is moving in a straight line. And the velocity at time t equal to 0, the velocity is 12 meters per second. And its acceleration, which is derivative of velocity, is given by 3 times cos of t by 4 meters per second square. For all values, and this is defined for all values of t greater than 0. Obviously, time, we cannot measure negative time, isn't it, when it is motion. So that's the information given to us. And what are the questions they are asking? So acceleration is given and velocity at initial value, time equal to 0 is given. The first question is, Find the expression for velocity. Expression. How is the velocity related with acceleration? Velocity is integral of acceleration with respect to time. Do we know the limits? Not actually, because they are just asking us to find the expression, which means I don't know between what values they are asking us. So when I'm integrating, I'm doing 3 integral cos t by 4 dt, which is 3 into 1 upon 1/4 is 4. Integral of cos is minus sine t by 4 plus c, right? This is the expression for velocity. What else we know is when t is 0, velocity is 12. If I substitute t as 0, sine of 0 is 0, so I get 12 is equal to c. So my final expression for velocity will be 12 minus 12 sine t by 4. Or I can take 12 common and write 1 minus sine t by 4. So that is the expression for, let's graph these two and check what is the graph of the acceleration, what is the graph of the velocity looking like. So the acceleration is given as 3 cos of t by 4. I am not using t, I'm using x on decimal. And what is the integral value? 12 minus 12 sine t by 4. Let's look at the acceleration. The acceleration is the blue curve. And so acceleration is between 0 to 2 pi, it is remaining positive. And the velocity is the green one. Now we are not able to directly see the relation very obviously, but if we see it if you zoom out and see, you will realize that the acceleration is a cos curve, so the velocity integral has to be a minus sine curve. But in addition to being minus sign, there is also a translation by 12, which is the initial value of the velocity. Okay. The next question says, sketch the velocity time graph for 0 to 8 pi. So they are asking for velocity time graph and 0 till 8 pi. Clearly showing where the curve meets the axis. So they want us to find out the intercepts, label the intercepts, and the maximum and the minimum positions, if any. So let's graph it. They only want us to graph the velocity. So let's take the acceleration graph out. And the axis has to be from 0 to 8 pi. This is how the graph is looking, and there they want us to mark the intercepts. 8 pi. 8 pi is approximately 8 into 3.14, so something less than 30s. 8 pi. Let's find out the value of 8 pi is 25.13. So somewhere there. So we have only one x-intercept between this, and the maxima and the minima, there is only one maxima which is occurring at 6 pi. There is no minima because 25, by the time we reach 25, we don't reach to any value which is either a maxima or minima. The other intercept that we have to mark is this 0,12, which is the initial value of velocity. So these are the 3 points that you will label when you are graphing. Is it easy to graph this without the calculator? Well, yes, think of it one by one. So if this question was without the calculator, sine x by 4, how is that? X by 4 means it is slower than the original sine function, correct? So I'm looking at a time period of 8 pi instead of 2 pi. That's my first thing. That's why they have asked us to graph it. Now I'm looking at 12 times this value. I'm translating it, then I'm reflecting it. Right? There is a minus. And then I'm adding 12 to it. So the graphing one by one, you will be able to realize. If it's only sine x by 4, at 8 pi, it is meeting the x-axis again. Now we are doing it 12 times. So again, these are our x-intercepts between 0 to 8 pi. And now when I put the negative sign, again, the intercepts remain the same. But as soon as I add 12, it gets translated. So now my intercepts change. My y-intercept is 12, and there is only one x-intercept between the 0 to 25 because my 8 pi no longer is the point at which it meets the x-axis because everything has got translated up by that amount. Is the time period the same? Yes. If I graph y equal to 12, you will realize that, yes, the time period is 8 pi. So that has not changed. But because of the vertical translation, now the x-intercepts is no longer there. So my x-intercepts are now at 2 pi and the maxima is at 6 pi and the value is 24. Okay, that's how we graph it without the calculator. The next question is to find the distance traveled by the particle before it comes to rest. So let's go back and look at the graph and see when will it come to rest. Even it comes to rest when velocity becomes 0, and velocity becomes 0 at 2 pi the first time. So the question says find the distance traveled before it first comes to rest. Distance traveled before first coming to rest, which means between 0 to 2 pi, I have to integrate the velocity expression and find out what will be the distance at time t equal to 0. It will be 0. Initial distance is 0. So I will integrate the expression for velocity with respect to time. And the integral is 12t minus 12 into 4. The integral of sine is minus cos, so plus cos t by 4 between 0 to 2 pi. Have I made any mistake before? The integral, have I taken the integral of cos as sine? I'm sorry, here I made a mistake. I should have had a plus sign here. So this is also plus. So my graph itself changes. There is a plus. So my maxima is at 2 pi and my x-intercept is at 6 pi. It has reversed. I made a mistake in the velocity integration. Integral of cos is sine. Integral of sine is minus cos. So I go back and change the sign here, which means the sign changes here as well. And now the value becomes 12 into 2 pi minus, if I substitute 2 pi, it will be cos of pi by 2, which is 0, minus, substitute the lower limit, 12 into 0 is 0, minus cos of 0 is 1, so minus 48. So the total distance is 24 pi plus 48. If it was a non-calculator paper, I will leave it as 24 pi plus 48. However, if I don't have the calculator, if I have the calculator, then I will also find the value of it. Right? Another particle. So in the same question, it continues. Another particle Q moves in a straight line, and its acceleration. So this is a second particle Q, whose acceleration is given by minus v square plus 4 meter per second square. At time t equal to 0, Q is at 2 meter per second velocity. So again, the initial velocity is given. The question now, instead of asking you the expression velocity, they're saying show that velocity is given by 2 tan of pi minus 8t upon 4. Okay. So let's look at the expression. Now here, acceleration is given by the derivative of velocity. And the derivative of velocity is, if you look at the expression, it's minus v square plus 4. So the rate of change of the velocity depends on velocity itself. Right now, we will not solve this problem. The reason is we haven't yet done differential equations. This particular solution will need that knowledge. And so we'll leave that here at this moment and come back to it. We'll go ahead and look at another question. But what I can do is I can show it to you right now and then explain it later again. So when we write this, I can bring in the variables which are of the same kind. So dv means small change in velocity, and I'm bringing the velocity expression here and the time variable on the other side. I understand we haven't done separable variables yet, but I'm just going ahead and solving it, but I'm going to explain this in the class as well. Now that I have separated the variables, I want to integrate to see that if I know the small change in velocity, what will happen if I integrate to get the total. So integral of dv upon v square plus 4 is equal to integral of dt. This expression 1 upon x square plus a square. If you remember, it is 1 by a tan inverse of x by a. And there is a negative sign because of this sign outside. And on the right hand side, you have t plus c. So tan inverse of v by 2 is equal to minus 2t plus c. We also know when t is 0, velocity is 2 meters per second. So tan inverse of 2 by 2 is equal to c. Tan inverse of 1 is pi by 4. Why should I take only pi by 4? Why not anything else? Well, that is the first value, and we know that when we are looking at inverse trig functions, we restrict the domain. So tan inverse always is values between minus pi by 2 and plus pi by 2. So the answer is pi by 4. There is no other answer to this. We know that tan can be 1 at many places, but when we are doing tan inverse, we make it a 1-to-1 function. So C is pi by 4, and the value, we can write it again, tan inverse of v by 2 is minus 2t plus pi by 4. So v by 2 is tan of pi by 4 minus 2t. Therefore, v is 2 tan of pi by 4 minus 2t. Is that what we wanted? Is that what they're asking? Yes. Show that the expression for velocity is. Again, this method has not yet been introduced in the class. This is a solution of differential equation. We will be solving it over time. The next question is, find the distance traveled by the particle before coming to rest. So again, we have to graph this velocity. This question will not come without the calculator because of the complexity of the graph. Right? So we want to graph 2 tan of pi by 4 minus 2t. Right? And we are going to look at time equal to 0 till, because it is till it becomes first time 0. So let's only graph till pi. And when we zoom in, you will realize that the first time it becomes 0 is at pi by 8. So I have to find the distance, I have to integrate the velocity only between 0 and pi by 8. So I can do it right here because it's a calculator question. It's going to be 0 till pi by 8. On your calculator, make sure that you put the brackets and then. So that's your distance, 0.34657 is the distance traveled before the particle comes to rest. Okay, let's look at one more question. A marine soldier steps out of a stationary helicopter. And the stationary helicopter is 1,000 meters above the ground. Let h be the height in meters above the ground and is given by, okay, so height is given by an expression. So I don't need another variable here. The height is given by the expression by s of t. For the first 10 seconds, velocity is minus 10t. Okay, the velocity of that marine soldier. Find the acceleration for time less than t. Calculate the velocity at 10 and show that distance traveled in 10 seconds. So they want us to find the expression for acceleration for time less than 10. Want us to find the velocity at time equal to 10. And they want us to find the distance traveled in the 10 seconds. Okay. So let's see the value. Acceleration is derivative of velocity. So we have minus 10t as the velocity for time less than 10 seconds. And therefore, acceleration will be minus 10 meters per second square, which is same as your g value approximately. Correct? Okay. And the velocity at 10, the velocity at 10 value will be simply minus 10 into 10, which is minus 100 meters per second. Now, why is this minus? Is more to do with the direction. So when I'm saying minus 10t, acceleration, if it is acting in the downward direction, and again here also I got a minus, means I'm considering down as negative and up as positive. That's why I'm taking that as a negative sign. What is the value of s of 10? Means between 0 to 10, integrate the velocity expression and find out. So minus 10t, integrate between 0 to 10, and the answer that you get is what the value is. Right. Let's look at the next question. a velocity function is given by 1 minus e raised to minus sine t square. Don't get worried about the complexity of the expression. If there is a unfamiliar function, then it comes only in the calculator. Right? The questions are first two time when direction when the direction of the particle changes. So when the particle is moving, the direction is changing. So the two times will be some t1 and t2 when the direction is changing. How will I know when the direction is changing? When the sign of the velocity graph changes, becomes from positive to negative or negative to positive, then I know that the direction has changed. For time t1, t less than t2, when does it have maximum velocity? That's the next question. And for time less than t2, when does the particle have minimum velocity? And the distance traveled between t1 and t2. So to understand all this, I think very important is to graph that function, because that's not a known function to us. So let's graph this, and it's completely okay for it to have this this kind of an expression. This is what it looks like. E raised to, and there is a minus here as well, minus, right? And I have to zoom in because if you look at the y-axis, it's hardly visible. So I'm going to look at minus 1 till plus 1 plus 5 or something. So plus 1. This is how my graph looks like, right? And they have not given us any domain. So the question is, when first two times when the direction changes. So the velocity is positive, and at 1.772 it changes direction because it starts becoming negative now. And then at 2.507 it from negative it becomes positive again. So these are the two times that we are clear now from the graph when the sign changes. Without the calculator, will we be able to do that? So look at 1 minus e raised to minus sine of t square. 1 minus e, when does it change sign? Well, okay, without the calculator seems kind of difficult for us to know, but sine x square, if sine was pi, and sine pi is 0 and e raised to 0 is 1. So if I can find out, when will the direction changes? The direction will change when the graph is having the x-intercepts. If I can find when does this graph become 0, then on the right side of 0, it will have to change sign. So let's think in that manner. If I had no calculator, 1 minus e minus sine of x square, when does this become 0? This becomes 0 when e raised to minus sine x square becomes 1. And it becomes 1 when the exponent becomes 0. And this becomes 0 when x square is either pi, 2 pi, 3 pi, and so on. So the first two times, right? The first two times will be pi and 2 pi. If x square is pi and 2 pi, so x is root of pi and root of 2 pi. Are these the two values that we are getting here? 1.772. Let's see. So square root of pi is 1.772, correct? And square root of 2 pi is 2.507. Yes, those are the two values. So if we didn't have a calculator, maybe that's what we could have done. When does it intersect the x-axis? Because when it intersects and it goes on the other side, it is crossing the x-axis. That means it is changing the sign. Okay. The next question is, in this interval between less than t2, where is the maximum velocity and where is the minimum velocity? For this, yes, we will need the calculator because we have to graph it. When does this become maximum and when does it become minimum? So at time 1.25, and again, if I have to think of when does it become maximum, it becomes maximum when this e power minus sine x square becomes the least. It becomes least means it becomes 0, or it will become least when sine of x square. Okay, sine of x square, if the maximum it can take value is +1 or -1. If it becomes +1, so I'm looking at this possibility that if I don't have the calculator, 1 minus e raised to minus sine of x square, when will this become maximum or minimum? If sine of x square is going to become equal to 1, which means x has to become equal to square root of pi by 2, at that place, this is what the value of the velocity will be. And when sine of x square is -1, then I'll get 1 minus e. So I have 1 minus 1 upon e or 1 minus e. These, let's see if those are the values of my maxima and minima. So square root of pi by 2. So square root of pi by 2 is 1.2537. Is that the place? Yes. And where does the minima occur? 2. Is that same as square root of 3 pi by 2? 2.17. Yes. It was more of a guess on what happens to the sine function. Because I know more about sine, I could guess that okay, the maximum value and the minimum value depends on what values can sine take. But don't worry, most of the time these kind of questions will come in the calculator, but making you think about this. So the time when it is minima and maximum velocity is shown, and now the question is the distance between this time t1 and t2. So what is the time t1? Time t1 is square root of pi. The time t2 is square root of 2 pi, and the velocity is 1 minus t square dt. So the distance traveled between them is integral of this. Again, I cannot solve this integral without the calculator. So I'm simply going to put it on the calculator. So I have to integrate this from square root of pi till square root of 2 pi. Make sure you put the brackets and dx. So the distance traveled is, I'm getting minus. What does that mean? Well, I'm not going to worry about the minus sign. I will simply think of it as the positive value or take the modulus of the answer. Let me show you why I'm getting it as negative. These are the two times between which I'm finding the distance between t1 and t2. Do you see that the green graph, the velocity graph, is in the negative region? So I'm going to get the area under the curve. When I do integrate, I'm doing area under the curve as negative answer. But that doesn't mean distance is negative, right? Distance is simply how much have I traveled, and that is still positive. So that's the value what you are looking at. So what I'm trying to explain to you in kinematics is that you have to understand the graphs of the functions that you are considering, and then you will need to find out the answers that are being questioned. So I'm going to share this link with you. 1 minute, where these questions that I have solved just now have been given, and some more of these questions have also been discussed. That this is shared on the chat screen and you can look at it. I will also put it on the posts of this channel. So you can go through those questions. Okay, thank you.